Hey guys, we're going to talk about inverses today. If you're following with the book, it's 5.6, inverses. And I'm sure you've heard inverses before, possibly with like, what's the inverse function? I'm sorry, not function, operation, right? The opposite operation. So keep that in mind when we're talking about this topic. We're still dealing with inverses, which is kind of like opposite, but now it's an inverse of a function, an equation of some kind, with x's and y's, because we're talking about, a relationship between the two. All right, so for example 1, find the inverse of y equals 2x plus 3. Please write that down. Always pause when you need to. I'm going to go through the exact steps of how to find it and then give you a chance to try it. Okay, so basically y equals 2x plus 3. Step 1, in order to find our inverse, is you switch the places of x and y. So where there was an x, there's now going to be a y, and where there was a y, there's now going to be an x. So when I switch them, I have x equals 2y plus 3. And now solve for y. So move everything away from the y. Subtract 3, and you're left with x minus 3 equals 2y. Divide by 2, and you're left with y equals x minus 3 divided by 2. I'm not going to simplify this. It's fine just the way it is. Another way you might see it is f of negative 1x, meaning the inverse of the function, equals whatever that happens to equal, x minus 3 divided by 2 in this case. Now I have 2 problems for you to try. You'll pause the video, try them, and then continue as you know. Or maybe you don't. All right. The second thing are just level 2 of this. We might not have linear functions. It might be a little bit more challenging. So I want you to see that with me. So still finding the inverse, but now we've got functions with like x squareds and cube roots. So we have to undo them. Still same step. We're switching the placement. So instead of a y, I have an x. So I've got y equals x squared is my original. My inverse, I'm going to switch. So I have x equals y squared. Now how do I undo a square? Got to take the square root. And the square root of x is the square root of x. The square root of y squared is y. So f of negative 1 of x, f of x, but the negative 1 of it, the inverse of it, is the square root of x. If you left it with y equals this and showing that that's your inverse, that's okay too. B, same idea. Y equals the cube root of x. Switch places. So I have x equals the cube root of y. Now undo that equation, right? What's happening to y? The opposite of a cube root, the inverse of a cube root, is a cube. So I cube both sides, and x cubed is x cubed. The cube root of y cubed is just y. So the f of negative 1 of x equals x cubed. Or keep it just the way it was. That's fine too. Okay? Again, you're going to try these 2 problems. Number 1 there is y equals x squared minus 10. And number 2 is y equals the cube root of x minus 2 minus 7 on the outside. Okay, try those problems, and then we'll regroup at the end for all of them. Okay, so let's actually talk about these 4 before we continue to the next part. So I'm going to bring this back and just get you the answers for these. So basically, I'm switching the places, right, and it ends up being f to the negative 1, so the inverse of x, equals negative x minus 2 divided by 5. And that makes sense, right? I have to subtract 2 and divide by a negative 5. I just put the negative out front, but if you kept the negative here, that's cool. For here, f of negative 1 to the of x. First, we get 3 times x plus 6, so you should distribute that 3 to 3x plus 18. Okay? The second part, so our answer, so that you have it, you're switching places, you get f of negative 1 of x equals the square root of x plus 10. The whole thing. That plus 10 is under the radical. The second part, f of negative 1 of x, the inverse is x plus 7 cubed plus 2. Right? All right, so hopefully you got those. All right, the last thing to talk about is if I give you 2 functions. Let's see if this will work. If I give you two functions, you have to determine if they are inverses. And basically all that means is plug one equation in for the other and make sure your result is just x. Okay? So for example, our first equation is y equals 3x plus 4. I'm giving you this information. My second equation is y equals x minus 4 divided by 3. And I want you to determine whether the two functions are inverses. So how do we do that? So we take the one equation, x minus 4 divided by 3, and I'm substituting it in for the x of the other equation. So I have 3 times x minus 4 divided by 3 plus 4. Then you just have to do basic math, simplify this. 3 divided by 3 cancels, and I'm left with just x minus 4 plus 4. Then minus 4 plus 4 is 0, so I'm left with x. So yay, that's true. Okay? So yes is the answer. They are inverses. That was the question. So I have a problem for you to try, and that's it. Okay, we have y equals 6x plus 12. And y equals x minus 6 divided by 4. All right, see how you do? Have a great day.